Good morning, everyone. Welcome to the class of CE333 Environmental Engineering 2. In our last class, we were discussing trickling filter. We discussed the mechanism of a trickling filter and various steps involving the treatment process of trickling filter. And we discussed this theory to determine the efficiency of trickling filter. Now, trickling filter can be applied in series like trickling filter 1, trickling filter 2. Okay, so this is the efficiency of trickling filter 1. Similarly, E2 is the efficiency of trickling filter 2. Okay, F1 is the factor which can be determined using this equation. Similarly, F2 is another factor which can be calculated using this equation. Here W1 is the load, BOD load per day, BOD load in pound per day. Okay, W1. So basically this is the load per unit time, where load is in pound, BOD load, and time is in day. Okay, V1 is the volume of the trickling filter. Okay, now let's look some example problems. In this problem, they're asking find acre feet. Acre is the unit of area and feet is the unit of depth, right guys? Am I right?
Yes, sir.
Yes, sir.
So acre feet, that actually refers to area, surface area multiplied by depth. So this is basically the volume, am I right? This is the surface area. Let's say this is the surface area A, and this is the depth. So volume of this trickling filter equals to area into depth. Clear? So acre feet
This,
actually refers to the volume of the trickling filter. So acre feet means volume of filtering media required to effect 85% removal. So E1, your E1 has to be 85% of BOD from 10 million gallon per day. This is million gallon per day of waste containing 180 milligram per liter of 5-day BOD. That means the initial BOD here, let's say we are looking at the plan from the top. So this is the trickling filter. Sewage is entering where L influent equals 180 milligram per liter. Okay, 180 milligram per liter. What is the Q guys here? Q is 10 million gallon per day. So Q equals to 10 million gallon per day. Single stage trickling filter. That means there is only one trickling filter, not multiple. 85% removal is required. So volume has to be calculated. So, if you go to this formula here, you already have volume here, right? You need to calculate this. This is the load per unit time. We can calculate this load per unit time. How? You know, if you multiply density rho with discharge, it will give you load per unit time. Here the load is mass actually. Let's see. What is the concentration, guys? Li, right? This is the concentration. Am I right?
Yes, sir.
180 milligram per liter. Milligram per liter. And what is the discharge, guys? Q 10 million gallon. So million means 10 to the power 6. Million gallon per day. So gallon per day. Now let's look at this. Milligram is what? Mass, right? Right? Hmm?
Yes, sir.
Okay. We're looking at the dimension. Okay. Looking at the dimension. M. Milligram is M. L is what? Volume. So L cube. Okay. Multiplied by what, guys? Gallon. Gallon is what? Volume, right? So L cube, right? And then day. That means time. So here milligram is the mass. So we have put mass. Okay. Then liter is volume. So we have put L minus 1 minus 3. Then gallon is for L cube volume and D is the time. So here it gets cancels out. So what remains is mass per unit time. So mass per unit time. Did you see mass per unit time? So if you multiply rho into Q, it becomes mass per unit time. Now the issue is here. This is milligram. You need to have this in what, guys? You need to have this in pound. Okay, and this is in liter. This is in gallon. We have to convert gallon to liter, right?
Yes, sir.
And day is day. So if you convert these units, gallon to liter and milligram to pound, then you need this number 8.34. That means if you put load per unit time, right? This is what? This is basically W1, load per unit time. This W1 is actually load per unit time. So W1 equals to load per unit time equals to rho into Q. 8.34 is the conversion factor. Therefore, if you put rho in milligram per liter and if you put Q in million gallon per day and if you multiply this with 8.34, so 180 milligram per liter 10 million gallon per day, and if you multiply 8.34, then you'll get this in pound per unit day. This is pound per day actually. They didn't write it explicitly, but this is pound per day. Okay, clear.
Yes.
जी सर.
So
Yes sir.
you actually get what? You actually get W1. So in this formula, you got W1. You need to know V1, by the way. You need to know V1. You don't know this. What is E1? E1 is the efficiency, and which is given 85% removal. So E1 is 85%. So you know this. The only unknown is F1 and V1. So you need to calculate F1. So let's calculate F1. What is the formula? Here is the formula. 1 plus R1 divided by 1 plus 0.1 into R1. What is the R1? R1 is the recirculation ratio. Now what are they telling? Telling that assume that sewage is not to be recirculated. So sewage is not, this recirculation is not present. That means this is absent. We are not recirculating the sewage. That means R1 equals to 0. So if you put R1 equals to 0 in this formula, you'll get 1 plus 0 divided by 1 plus 0.1 into 0 square. So 1 plus 0, 1 plus 0.1 into 0 square. If you put this here, okay, you'll get F equals to 1. Now, if you put in this formula, if you put the value of E1 as 85% in percent, this has to be in percent, then W1 is what, guys? Pound per day. W1 is 15,000. 15,000 pound per day. And if you put F1 equals to 1, then only unknown is what, guys, here? V1. So you calculate V1. So that's what they have done here. Your V1 will be in what unit? It's given. It's acre feet. So this is in acre feet. Did I make it clear?
Yes, sir.
जी
Okay.
sir.
Now, in the second part of the problem, B, here, they're asking the BOD loading of the filter per acre feet. BOD loading of the filter per acre feet. Per unit volume, actually. Per unit volume. So this is actually simple. What is the total loading, guys? Let's say the volume of the trickling filter is V. Volume of the trickling filter is V. This is the volume. So in the full volume, how much load you are applying? W. What is the load, guys? 15,000 pound per day. So this is 15,000 pound per day. What is the volume? We just calculated this. What is the volume? 34.8. 34.8 acre feet. So in this total volume, you are applying how much load? 15,000 pound per day. So in 1 acre feet, how much load you are applying? 15,000 divided by 34.8. So this, tell me the value, please. Pound per day per acre feet. Tell me the value, please.
So 43.10.
43.10. So this is basically for 10. or um,
40, 431.03.
431.03.
431.03.
So 431. So 431 pound per acre feet. This is per day also. They didn't write it explicitly. This will also be pound per day per acre feet. So you can write it pound acre feet into day. Pound per acre feet per day. Okay, clear?
Yes, sir.
Yes, sir.
The BOD loading and the hydraulic loading, if the filter is made 6 feet deep, that means the surface loading. That means the surface loading. So that means here you got it in acre per feet. Now you need to get this in acre. So pound, here this is in pound per volume. Okay, here this is in pound per volume. Volume is acre feet. Now you need this in pound per acre. That is area. So you need to do what? You need to multiply this with the depth. Am I right?
Yes, sir.
So if you multiply this with the depth, that means feet, then this will be cancelled out and you will get pound per acre per day. Okay. So you multiply this with depth, you get this. Okay. So BUD surface loading. That means per unit surface area. Or you can do it in this way also. Like, what is the surface area, guys? Volume equals to area into depth. What is the area, guys? Volume is what? Volume is 34.8. 34.8 acre feet. What is the depth, guys? 6 feet. So feet cancels out. Tell me the value, please. 5.8.
5.8, sir.
5.5.
8.
5.8.
5.8. So this is acre. So in 5.8 acre, you are applying how much load? You are applying 15,000 pound per day. So in 1 acre area, you are applying 15,000 divided by 5.8. Tell me the value, please.
Sir, 2586.06.
2.86.
Sir, 2586.
2586. Yeah.
0.20.
0.2. So 2586. Same thing. Okay. So you can either go in this route or multiply this with 6. Same thing. Clear?
Yes, sir.
Pound per acre. This is pound per day. And this is acre. So pound per acre per day. Pound per acre per day. Hydraulic loading. This is kind of hydraulic loading. 34.8. This is actually Q. 10 is what? Q, right? And this is actually what? Volume divided by depth. That means area. This is actually the velocity. So velocity of the flow, velocity equals to what? Q by area. Clear? Right?
Yes, sir.
So if you look at the trickling filter like this, right? Here there's a filter media. Now the water is moving like in this direction. Hmm. So this is the velocity. And what is the cross-sectional area? This is the cross-sectional area or surface area. So velocity is perpendicular to this plane. So area is this, and Q is this. So velocity is, what is the Q? Q is 10 million gallon per day. What is the area? You just determine what is the area. Area is 34.8 divided by 6, right? So 34.8 divided by 6. So what about the value? This is 1.74 million gallon per acre per day. Clear? This is million gallon per day, and this is acre. So million gallon acre per day. Million gallon per acre per day. Clear?
Yes,
Yes,
sir.
sir.
Okay. The next problem. Here. The BOD of a raw sewage to be received at a proposed treatment plant with a single stage high rate filter. So you have a single stage, only one filter, is 240 milligram per liter. That means this is 240 milligram per liter. L. The plant effluent is to contain a BOD of 40 milligram per liter only. That means the effluent BOD, final BOD, should be 40 milligram per liter. If the flow is 1 million gallon per day and BOD removal in the primary clarifier, that means before you put the sewage into the trickling filter, you put this in a primary clarifier, PC, where some part of the sewage will be treated. Okay, how much? 35%. So 35% will be removed here. 35% will be removed here. So what is Li? Tell me, what is Li? 35% of L will be removed in PC. Then what will be Li? For this one, Li will be 240. That means 240. How much will be removed, guys? How much will be removed? 0.35, right?
Yes,
So
sir.
how much will be remaining? Li. So remaining is 1 minus 0.35. 35% of 240 milligram per liter will be removed. Then how much will be remaining? 1 minus 0.35 will be 1 minus 0.35 of 240 will be remaining, right? So remaining will be emerged from the primary clarifier. Did I make it clear?
Yes, sir.
240 is entering, 35% has removed here, gone in the primary clarifier. How much will be discharged? The remaining one. What is the remaining one? 1 minus 0.35 of 240. That will be remaining. So this will be Li for the trickling filter. Clear? The trickling
Yes,
Li
sir.
will be 240 into 1 minus 0.35, 156. So as you can see, 240 has become 156 here. So reduced. Who has reduced this, guys? Who has reduced this? Primary clarifier. 240 minus 156, that much has been reduced by primary clarifier. Okay. Now we are recirculating the water R. After recirculation, uh, this is 240, right? And this is what? 156. This 156. So now look at this. This Li, this Li, and this R, let's say this is LR, recirculation, LR. Basically LR and LE is same. Let's say LE. So together, by mixing this LE and LI, it becomes LF. It becomes LF. So this Li and this Le get mixed up, and after mixing they becomes LF, concentration. Okay, is it clear?
Yes, sir.
So after treatment in the trickling filter, you get Le. You get Le. This is Le. This is Le. There's nothing mixing up, so all will be Le, and then again Le. Okay. So this is Le, this is Le, this is Le. There's nothing mixing up. Okay, the same water. So all are Le. This is also Le. So this Le goes here, gets mixed up with Li, and becomes LF. Okay, so this is Li, and finally it becomes LF. Now here Le is given, which is 40 milligram per liter, which is 40 milligram per liter. Then what else is given? Let's see. If the flow is 1 million gallon per day, so Q is given. BOD removal in the primary clarifier is 35%. I already told you this is E equals to 35% here. Filter loading is 0.45 pound of BOD per square feet of the filter surface per day. What should be the volume of the sewage recirculated and the diameter of the filter? So you need to calculate the R, and from the R, you need to calculate the volume of the sewage recirculated and the diameter of the filter. Okay, fine. Now, the efficiency in this trickling filter is what? 63%. Here the efficiency is what, guys? 63%. So as I told you that if the efficiency is 63% here, This is what? LF. This is LE. This is LF. This is LF. This is LE. So LE will be 1 minus E into LF. LF. Clear? LE will be 1 minus E into LF. Did I make it clear?
Yes, sir.
So, what is your LE? LE is given. This is 40. What is your E? This is 63%. So 1 minus 0.63. So what is LF? 40 divided by 1 minus 0.63. Clear? 108 milligram per liter. Clear?
Yes, sir.
40 divided by 1 minus 0.63. 40 divided by 1 minus 0.63. 108 milligram per liter. Okay. Now, let's see. Let's focus this point. I'm talking about this point. This point. Okay. In this point, three flows. We have three flows actually. This R, that is recirculation, QR here. Let's see, this is the pink one. Okay, this is the blue one here, LI. This is the LE. This is the red one. So this discharge, this pink color, this is QR because this is going to be recirculated. This is the recirculated flow. So this is QR. This is QI. This is the initial flow, QI. And finally, according to the mass balance formula, the amount of flow that you are getting, QI plus QR, should be equal to the amount of outflow. So inflow should be equal to the outflow. Am I right? Inflow should be equals to the outflow. Inflow should be equals to the outflow. So in this point, this is entering, so this is inflow, this is QR, this is QI. So inflow equals to QR plus QI equals to what is the outflow? This is getting out, and this is QE, right? No, sorry, this is Q. What they have denoted is whatever. Let's say this is QY. So equals to QY, right? So QY, this is actually summation of QR plus QI. Did I make it clear?
Yes, sir.
Yes, sir.
Now, in this point, the amount of what is the Q? This is QR, LE, right? This is QI, LI, and this is QY, L. But they are denoting this F, so LF. Now tell me, Q into L. What is this? L is the milligram per liter. So this is the concentration, rho, and Q is C. So rho into Q is what? Load per unit time. Am I right? Load per unit time. Mass per unit time, or you can tell mass per unit time. So mass per unit time equals to rho into Q. Clear? Clear?
Yes, sir.
Yes, sir.
So amount of, according to the mass balance, conservation of mass, the mass amount of mass that is entering M1 per unit time, entering M2 should be equals to the amount of mass heading out. So inflow of mass should be equals to the outflow of mass. That means M1 plus M2, they are getting in. These two are getting in. What is getting out? This is getting out. This is getting out. Should be equals to the M3. This is mass per unit time, by the way. So mass per unit time is what? Q into L, or rho into Q. L into Q. So L, M1 is what? LE into QR. M2 is what? Li into Qi equals to M3. M3 is what? LF into Qy. What is Qy, guys? Qy is what? Qi equals y equals to Qr plus Qi. So Qr plus Qi. Clear? Clear.
Yes, sir.
So what is if you reorient this equation, you will get QR equals to this. From here, you have LE into QR plus Li into Qi equals LF into QR plus Qi. So if you reorient this equation, you will get QR, which will be this. Okay. From this here, this is the same equation, this and this. From there, you will get QR equals to this. So volume of the sewage recirculated. QR is what? QR is the volume of sewage recirculated per unit time. So this is QR actually. Discharge. Volume of the sewage recirculated per unit day. That means the QR. This is actually QR. So QR is what? QR equals to this. So Li is what, guys? Li is 156, right? Li is what? 156. Then LF. What is LF, guys? LF is, you just calculated this. This is 108. This is 108. 156 minus 156 is Li. And LF is what? 108. Divided by LF again. LF is what? LF is 108. So 108. And then LE. LE is given. LE is given. That's 40. This is 40. Multiplied by QI. What is QI, guys? This is QI. This is QI. Same thing. QI is what? QI is 1 million gallon per day. That means 1 into 10 to the power 6. 1, 2, 3, 4, 5, 6. 4, 5, 6. So gallon per day. Clear?
Yes, sir.
Okay. Now R equals to what? R equals to actually R equals to QR divided by QI. That means portion of QR divided by QI. That means portion of QI that is recirculated. QR divided by QI. R equals to what? R equals to QR divided by QI. That means what is the fraction of the sewage that is recirculated? Okay. So QR, you have calculated QR, that is this gallon per day, and QI is given, that is 1 million gallon per day. So you get 0.706. So total hydraulic load total hydraulic load is what? This is the total hydraulic load, am I right? That is being applied to the trickling filter. Look at this. What load is being what discharge is being applied finally? This one is being applied finally, red one, right? So red one is what? Red one actually qy. I just said this is qy. Y equals to qi plus qr. So qi plus qr is 1.706 million gallon per day. Just sum it up. qi equals to 1 million gallon and qr equals to 0.706 million gallons. So 1 plus 0.706. Clear? Clear.
Yes, sir.
What should be the volume of the sewage recirculated? That is the volume of the sewage recirculated per unit day. Per day. And the diameter of the filter. Diameter of the filter. Total BOD load applied on the filter. What is the total BOD load applied on the filter? As I told you previously, that load per unit time equals to rho into Q. So Q, total BOD load applied on the filter should be what? Rho into Q, or Li. Rho is Li actually. Rho equal to L actually. L into Q. So L into Q. What is the BOD load applied on the filter? This is the red color, red one, right? So LF into QY. LF into QY. What is your LF, guys? LF equals to 108. LF into QY. And QY equals to what? QI plus QR. That is 1.706. So this is 1.706 and LF equals to 108 milligram per liter. And you know you need to have a conversion factor 8.34. Okay, so this will be pound. Basically, this is pound per day. Clear?
Yes, sir.
Okay. Now they're telling filter loading has to be 0.45 pound of BOD per square feet. It has to be 0.45 pound of BOD per square feet. That means they are telling you that load per unit load means load per unit area has to be 0.45. Load per unit area has to be 0.45. So guys, load is what? This 1537 per day. 1537 divided by area, right? This is the area, equals to 0.45. Tell me the value of the area, guys. Tell me the value of the area.
Sir, 691.65.
1537 divided by 0.45.
691.65.
Can you, someone, everyone do it? Everyone, bring out your calculator and do it. 1537 divided by 0.45.
3415.56.
3415 square feet. Okay.
Sir.
So sorry,
Now diameter of the filter, it's easy. This is area equals to This is circular, right? This is circular. So pi by 4 d square. You don't need to use this, just use this. Uh, so d equals to 4a divided by pi. And this is actually the same thing, by the way. So area you have calculated. What is the area? Area is this. So from there you calculate diameter. Done. You'll get this 66 feet. Okay. Clear?
Yes, sir.
Any questions? No questions. Okay. And the next problem that a single stage filter is to treat a raw sewage flow of 1 million gallon per day with a BOD of 240 milligram per liter. It is to be designed for a loading of 3,000 pound of BOD in the raw sewage per acre feet. Okay. And the recirculation ratio has to be unity. That means R has to be 1. Unity means 1. R has to be 1. What will be the strength of the effluent? Look, initially, there is only one filter. Initially, there is only one filter. We don't have this initially. This. Okay. What will be the strength of the effluent? In A, they are telling us what will be the strength of the effluent. So, treat a raw sewage flow of 1 million gallon per day. So Q equals to given is 1 million gallon per day with a BOD of 240 milligram per liter. So L is given as 240 milligram per liter. Okay. And the recirculation ratio has to be unity. So this is 1. It is to be designed for a loading of 3,000 pound of BOD in the raw sewage per acre. That means they are telling you that the load, BOD loading load per unit volume should be 3,000 pound. Load per unit volume should be, they're telling you load per unit volume has to be 3,000 pound per acre feet. They have limited this. Okay. Okay, fine. So recirculation ratio is given. This is a unity. So if you go to the formula here, F1 for the first, this is this 1 plus 1. You have a 1 plus 0.1 into 1. R1 equals to 1 whole square. Tell me the value, please. Use F1, not F2. Okay. We're in a single stage filter. Tell me the value, please. Hello.
Sir, 1.65.
1.65. So 1.65. Now, in problem number A, BOD load applied on the filter. That means this Li. What would be Li, guys? 35% removal in the primary clarifier. So Li will be, as you know, that effluent 1 I equals to 1 minus E into the L initial. So L So this is 1 minus what? 1 minus Li will be 1 minus E is what? 0.35. So 0.35 into L, right? L is what? 240. L is 240. So whatever you get this. Okay. Now, BOD load applied on the filter. As I told you, load per unit time is what? Load per unit time is what, guys? Load per unit time equals to L into Q. Am I right? Or rho into Q, whatever you tell it. Right? Right?
Yes,
Yes,
sir.
sir.
So if you look at this trickling filter, load in this trickling filter, how much load you are applying? This load. So Li, this will be Li into Q. So Li is what? Li is 1 minus 0.35 into 240. 1 minus 0.35 into 240 multiplied by Q. This is in milligram per liter, by the way. This is in milligram per liter. Q is what? Q is given. What is Q? 1 million gallon day per day. So 1 million gallon per day. So you have to multiply this with 8.34 to convert the unit to pound per day. Pound per day. So tell me the
Sir,
value.
one three, sir, one three zero zero one.
1301. Let's say 1300. 1300 pound per day. Pound per day. Actually, we didn't write the day explicitly. Okay, clear? Clear.
Yes, sir.
Clear, guys. Okay.
Yes, sir.
Yes, sir.
Now, this load, let's look at this formula now. I'm talking about this formula. This is given, by the way, guys. And load means load per unit. Here, load means load per unit time. Okay. So load per unit time is what? Now 1300. So 1300 divided by volume equal to 3000. What will be the volume then? What will be the volume? 3000 divided by 1300, right?
Sir, zero point
Divided
four
by
three.
1300. 0.43 acre feet. 0.44 or 43 acre feet. Clear? Clear. Volume equals to 1300 divided by 3000. 0.44 acre feet. Clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Now, what will be the strength of the effluent? Fine. To know the strength of the effluent, you need to know the efficiency. So let's go back to the formula here. E1. W1 divided by V1 F1. This is W1. This is V1. This is F1. So you know F1, you just calculated F1 1.65. So this is 1.65. Okay. Now volume, this is V1. You just calculated this 0.44. This is 0.44. And W1, what is the load that is being applied? Okay. This is the load. 1300 pound per day. So this is W1, just 1300 pound per day. Okay, clear?
Yes, sir.
जी सर.
73.5%. Now this is easy. Strength of the effluent. So Le. What is the strength of the effluent? Le. First of all, Le. Let's say this the efficiency here is E trickling filter. So Le trickling filter. Efficiency of the trickling filter. So Le will be 1 minus efficiency of the trickling filter. Le will be 1 minus efficiency of the trickling filter multiplied by Li, right?
Yes, sir.
Fine. So you're done. 1 minus, what is the efficiency of the trickling filter? We just determined 0.735. So 0.735 multiplied by Li. Now what is Li? Li is this. Remember, Li is this. Li is this, right? So that will be 1 minus 0.35 multiplied by 240. Clear?
Ji, sir.
So 1 minus 0.735 multiplied by 1 minus 0.35 multiplied by 240, that is Le, effluent BOD. Yes, so that is 41.34 milligram per liter. Okay.
Yes, sir.
Okay. Now in the second part, last part, they are asking that if it is proposed to use a two-stage plant, that means instead of trickling filter 1, you are using 2 trickling filters, and the recirculation ratio remains to be the same. That means R equals to 1. Unity. Determine the BOD of the final effluent. In that case, look, you are introducing another trickling filter here. You are introducing another trickling filter here. Okay. Previously it was not here. Now you have another trickling filter in B. So if the two-stage filter is used, then the volume of each filter will be what? Then volume of each filter will be half. So 0.44 divided by 2. So each filter will have 0.22. So this will be 0.22. This will also be 0.22 volume, right? So together that makes 0.44. Clear?
Ji, sir.
Yes, sir.
So this 0.22 acre feet. Now you calculate E1 and E2. To calculate E1, you need to use this equation, right? Where you know W1 is, you just calculated this. You just calculated this. W1 1300, this 1300 W1. What is V1, guys? Now remember, previously you put V equals to 0.44, but now V1 equals to 0.22. You have to carefully notice this difference. In A, there is only one stage trickling filter. So the volume of the single filter was 0.44. But now since you have two filters, therefore the each of the filters now have each of the filters now has 0.22 volume
0.22.
instead of 0.44. So 0.22, and F1 is the same as you calculated. This is 1.65. So W1 divided by V1 F1, this W1 divided by V1 F1 equals to 3581. E1 equals to 100 divided by 1 plus 0.0085 root over W1 divided by V1 F1. So they just determine the value separately. That's it, nothing else. So this is the efficiency of the first filter, right? As you can see, since you have reduced the volume, the efficiency has reduced now. But no problem, we still have another filter, right? So from here, there is another filter. So let's see. BOD load applied on the second stage filter. On the second stage filter, that means here. On the second stage filter. BOD load applied on the second stage filter. Let's say this is 2. Let's say this is L1. Okay. And this is L. L is what, guys? L is what? L is 240. So efficiency for the first trickling filter is what, guys? E1 66.28. So here E1 equals to 66.28. Are you following me? Percent. Are you following
Yes.
me?
Yes, sir.
Yes, sir.
We don't know E2 yet, by the way. Okay. Now BOD load applied on the second stage filter. This is L2 concentration, and say this is W1 and this is W2, the load in trickling filter 1, W1, load in trickling filter 2, W2. So W1, we just calculated this. This is 1300. This is 1300. So what will be W2? Easy. W2 will be 1 minus E1 multiplied by W1, right? W2 will be 1 minus E1 multiplied by W1, because some part of it will be removed in TF1, trickling filter 1. So this is W1 is what? W1 is 1300. So this is 1300. And 1 minus E1 is what? E1 equals to
66.28.
66.6628, right? That's it. So 438 pound. And now you go to this formula E2. What is the formula of E2, guys? The formula of E2 is this. The formula of E2 is this. Here is the formula. Okay. So E2 equals to 100 divided by 1 plus 0.0085. E1. What is the E1, guys? E1 equals to 0.6628. So E1 equals to 0.6628. E1 equals to, here E1 equals to 0.6628. W2, you just calculated W2. Where is calculated W2? Here, W2 equals to 438. So 438. So W2 equals to 438. V2, I already told you, each of the filter now has 0.22 acre feet volume. And F2, you need to calculate F2. Okay, what is the formula of F2, guys? This is the formula of F2. 1 plus R2 divided by 1 plus 0.1 into R2. R2 equals to 1, unity 1. R2 equals to 1. So you just calculate F2. Clear?
Ji,
Clear.
sir. Yes, sir.
So you
Yes,
put
sir.
1.65 here. So you got 53.3%. So you know this now, 53.3%. Now they are telling what? Determine the BOD of the final effluent. That means LE here. Simple. What is LE? LE will be, LE will be, this LE will be from here. LE will be, if you start from here, where are they starting from? They are starting from here. No problem. This is 240, right? So if you start from here, all the way from here, right 240. Okay. Then some part of it has been treated in primary clarifier. What was the efficiency? E, let's say E. So 1 minus E. Then it becomes this. It has been again reduced by trickling filter 1 with an efficiency of 1 with an efficiency of E1. So it will be 1 minus E1. Then you get L2 and it has been again reduced by trickling filter 2 with an efficiency of E2. So this is 1 minus E2. Clear, guys?
Yes, sir.
So you write this 240. Let's look at this. 240. 240. What is the efficiency in primary clarifier? What is the efficiency in primary clarifier? 35%. That means 0.35. Okay. What is the efficiency in primary clarifier 1? E1 66.28. So 0.6628. What is the efficiency in trickling filter 2? E2
Sir, 60.
53.3. So 1 minus 0.533. This is 1 minus 0.533. Okay. So finally you get 24.57 milligram per liter. Clear?
Yes, sir.
Any questions?
No, sir.
No, sir.
Okay, if you don't have any questions, so that's the end of the lecture. Thank you very much. Have a good one and stay safe.